Okay. So, this says prove using coordinate geometry quadrilateral ABCF as a parallelogram. How do you know if something's a parallelogram? Both pairs of opposite sides parallel. Okay? Right now, we have a bunch of theorems about parallelograms. We have 4 theorems about parallelograms, but they all start off with if a quadrilateral is a parallelogram, then you get these conclusions. Okay? None of them start off with if this is occurring, then you get a parallelogram. So my argument is because they're worded that way, we don't have any theorems that are going to allow us to prove this thing to be a parallelogram. The only thing that we have that allows us to show this thing's a parallelogram is the definition. We have to meet the criteria that's presented in the definition. Kenyon said that both pairs of opposite sides are parallel, right? Okay. When we're working in the coordinate plane, what characteristic about lines or segments will tell us they're parallel? They have the same slope. So we're going to look at AC. Okay, so AC, and we're going to figure out if the slope of AC is the same as slope BF. Is that all right? Okay. You guys remember your slope formula? Y2 minus Y1
equals M x2 minus x1.
Okay. Or we can use that, right? Lucas,
What?
do you use slope in Algebra 2?
Yes.
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 Okay. I gave a final to my college algebra students, which is the class you take after Algebra 2. It had several slope questions on it. Okay. Now, in those courses, a lot of times you take finding slope is a kind of a preliminary process. You do that, and then you do other things with it beyond that. Okay. But you have to be able to find slope in high school math. All right. So the sooner you can justify this process, the better off you're going to be. Okay. And it's just subtraction, guys. It should be pretty easy. I want to find the slope of AC. Okay. So slope of AC. I like to stack my ordered pairs like this because now I can just subtract straight down with my y's. What's 5 minus 7? -2. And now what's 0 minus 5? -5. So that's going to reduce to 2/5, right? Okay. Now, again, with your pictures, hopefully that should make sense. And if that line is, or segment is moving from left to right and it's moving up, it's increasing, it's got a positive slope, right? Okay. And the rise is a little bit slower than the run, so that kind of makes sense to us visually that this should probably be 2/5. Okay. Obviously, you could count, right? But you remember me telling you that you don't want to rely just on counting because what happens if I start giving you really nasty numbers for your ordered pairs? That might kind of fall through for you. So now I'm going to do slope of BF. And that's another thing on the end of course exam. If you're able to count, that's great. But it's going to say show work. Is counting showing work? How do you show that you've counted something? You can't, right? You have to do this algebra, this math, this subtraction is the counting that, or the way that you show that counting. Does that make sense? So you have to be able to show this. Now we'll find a slope of BF. Okay, so subtract those y's. What do you get? Subtract the y's, you get -2. Subtract the x's, you get, that's your -5. So then I get 2/5. So this slope is 2/5. So what's that tell me about those two lines? Parallel. Okay? Does that tell me this is a parallelogram? No. Does anybody know what it tells me? Bare minimum this shape would be? It would be a trapezoid, bare minimum. Okay? But once I find out something about the other sides, it'll allow me to better classify it eventually as a parallelogram. So let's find AB. Slope of AB. All right, subtract those y's. What do you get? +4. Subtract the x's. -4. So that reduces to -1. I'm going to write that way just for later purposes. And then slope CF. So subtract these y's and subtract these x's. And again, negative 1 over 1, right? So does that tell me that these two are parallel? Okay. So if that's the only thing that you put down on the end of course exam, okay, and you're going to eventually get into maybe other courses, maybe you take some college courses at some point, you might get a professor that says, okay, that's fine, or maybe a physics course. Physics does this a lot, where you do the calculations and that's great, but you're not getting a single point until you explain what those calculations mean. Okay? I had a professor in my graduate courses. It would take like 3 pages of paper to do a problem, okay? But then it would take like 2 more pages to explain why those numbers that we just came up with address the original issue, all right? And if I didn't have any of that explanation, I don't get any points of all the work that I've done, okay? Now, it's kind of I think, a jerky move, but at the same time, it does force you to get a better grasp of the material and understanding of the math. So what we want to do here is say, because we have shown that both pairs of opposite sides have the same slopes, it is then true that both pairs of opposite sides are not equal. Same slopes, they are parallel. And this meets the condition set forth in the definition of a parallelogram. Now, it doesn't have to be worded that way. You can say, because I found both sets of slopes to be the same, then I know by definition this thing's going to be a parallelogram. Somehow phrase it so that you know, that you're able to communicate with somebody what the algebra is telling you. Okay? That's something that I think is very important for us to be able to do. A lot of you are very skilled with the work process, okay? Being able to go through and do the calculations and do all the things that we need to. But then when I can ask you questions and we want to have a conversation about what that work tells me or tells you, there's where we struggle, okay? If you've ever tried to explain something that you've done in this class to somebody else, or try to teach somebody else something, that might be hard, but you can maybe show them. Does that make sense? Showing and teaching is a little bit different. I think it's very, very important for us to be able to start understanding not only what calculations are, but what conclusions do they lead us to? Okay? So those calculations of slope lead us to the definition of a parallelogram. Is that okay? All right, so the next thing I want to do is I want to find the distances of these 4 segments. Okay? And what's going to be nice is that we really only, if we're thoughtful about our process here, we only need to find 2 distances. All right, if you remember the distance formula, is this, correct? Okay. Weren't all of these things over here, all these fractions, weren't they a bunch of y2 minus y1s and x2 minus x1s? Yeah. So why, if I'm writing down my slopes, and I'm writing down those fractions, then I've already done all the work, or most of the work, in regards to finding distance. So if I want to find the distance of, let's say, AC, the distance of AC, okay, it's going to be x2 minus x1 for A and C. Well, that's this information right here, right? x2 minus x1 is that -5. What do I get if I square -5? 25, okay? y2 minus y1 is that -2. What do I get if I square that? 4. So I get radical 29, right? Does that make sense? Do we know what kind of number 29 is? It's prime. Okay, so if it's prime, by definition of what a prime number is there a perfect square that is a factor of 29? No, because by definition, a prime number is a number greater than 1 that is divisible by only 1 in itself. So that means there are no perfect squares that are bigger than 1 that divide 29. Okay, so radical 29 is that length right there. Okay. Now, I did not tell you, I probably should have, how to leave your answers. When there are no directions, it's fair game. Well, do whatever you want to do. You want to leave it as a radical 29, leave it as a radical 29. If you want to put it as a decimal, put it as a decimal. Okay? Here's my thought. If I just did it with radical 29, if I want to write my answer as a decimal, don't I have more work to do? I got to type my calculator, right? Do I want to do more work? No, leave it as radical 29. There's two things there. That's the best answer, because when I do type it in my calculator, that number right there, that's not radical 29 anymore, because that 7 might not be a 7. That might actually be a 6, because the calculator might be rounding up. Does that make sense? Or it might be a 7, and we've cut off all these values over here to the right. But that is not radical 29 anymore. So is that all right with everybody? So leaving it as radical 29 is the best thing to do, because it's exact, and it was kind of like the lazy method. Okay, I didn't have to grab my calculator and do anything else with it. Okay, so let's now do the opposite, BF. What should, if this is already a parallelogram, we've proven that's a parallelogram, what should that distance be? It should be radical 29, right? We have a theorem that says opposite sides of a parallelogram are congruent. Now think about this. If I want to find distance B to F, let's come over here. We're going to be using this stuff now, right? Well, is that -2 and that -5 the same as the -2 and -5 we used here? Okay, so if you square -5 and get something other than 25, we've got a problem, right? If you square -2 a second time and get something other than 4, we have a problem. What's 25 plus 4 again? Radical 29, okay? So that's kind of saying that we really didn't have to do any extra math there. We should know that that's radical 29. Because we're using the same x2 minus x1 and y2 minus y1. Is that all right? Okay. Let's go and look at the distance for A to B. When I did slope AB, we did that slope right there. Okay. When I did y2 minus y1, what number did that give directly? It gave 4, right? Okay. When you did x2 minus x1, it gave you -4, right? It didn't. This was a reduced value, -1 over 1. When I'm going to use my slope to help me do my distance, you have to use the unreduced version. Okay. Because you're looking for what the x2 minus x1 was, not what the fraction or the common value that got brought out was. Does it make sense? Okay. So what's 4 squared? 16. What's -4 squared? 16, right? Okay, so now, that was weird. What is, okay, so radical 32. Okay, can I take 32 and break it down? Okay, because there's perfect squares in there, right? So I can go 2 and 16, 2 and 8, 2 and 4, 2 and 2. It's kind of the most direct way, right? That's a group of 2s, right? I can come out front. Is that another group of 2s? I can come out in front. Does this 2 have a group to belong to? Lonely, so it stays underneath, right? So what's 2 times radical 2? 4 radical 2, right? That's something we can do, correct? Let me ask you this. Is there a quicker way? What's a quicker way? Okay, so here's this is repetitive. 16 plus 16, that's repetitive addition, right? What's another word for repetitive addition? Multiplication. multiply by 2, right? So I get 16 times 2, correct? Now I'm going to explain later why we can do this. But we can break that up into its own. When you have a radical of products, you can break it up into a product of radicals. Okay? So what's radical 16? 4, and then radical 2 is just radical 2, right? So there we get A. What are we doing? AB here? Yeah, AB was 4, radical 2. What's this one over here going to be? I'm not going to do it, but it should be 4, radical 2 again, right? Now, again, I did not tell you how you had to write your answer. So if you left it as radical 32, that's fine. If you went and figured out what that was, radical 2 is 1.4144, something like that. Multiply that by 4. You write it as a decimal, go ahead and do that. Okay? Before we go on to the next part, let's do a little bit of algebra here, or number sense. There was a number, radical 29, a moment ago, right? If I were to give you a number line, and let's just say zeros there, we go 1, 2, 3, 4, 5, 6, 7. And I gave you the marker, and I told you, go up there on that number line and put radical 29 in a roundabout, approximate position. Could you do that without a calculator? How? Okay, so there are 2 perfect squares that sandwich 29, right? What's the perfect square that is less than 29? Square root of 25, right? What's the square root that is bigger than 29? 36. Okay? What is radical 25 the same as? 5. What's radical 36 the same as? 6. So does it make sense that radical 29 is somewhere between 5 and 6? Now look at this 29. 29, is it closer to 25 or is it closer to 36? It's closer to 25, right? Now is it about in the middle? Or what number would be the middle of 25 and 36? Yeah, about 31, right? 30.5, okay? So this one's a little bit, so right in the middle would be 5.5, right? This one's less than that. So you can kind of guesstimate, maybe this is about 5.3, 5.4. Okay, so if you calculate radical 29, it gives you 5.38. So it gives you an ability to kind of know where it goes on the number line, right? Okay, that's number sense. That might be something that they ask you on the end of course exam. Okay, they might give you the non-calculated portion and say, here are some numbers, put them in order. Okay, and that's kind of the approach that you would use. Okay, the next part, several people were questioning because it says locate the intersection of the diagonals. Okay? Here in order to address this, we have to know the relationship between the diagonals. What do the diagonals do to one another? They intersect, but how? Not necessarily perpendicular. They might be. They bisect each other. If I look up the definition of bisect, what vocabulary word is going to be in that definition? Midpoint. Okay? So whenever something says it's bisecting, there's a midpoint present. That's what they're asking for here. They want you to find that point right there, which is a midpoint of either CB or AF. Okay, so if I look at B and C, does anybody remember the midpoint formula? Good. Okay, so we're going to add our x's, divide by 2, add our y's, divide by 2, right? What's 4 plus 5? 9 divided by 2 is 9 halves. 1 plus 7? 8 divided by 2? 4. You're going to see in a moment why I left as 9 halves. Okay, so that's looking at using BC. So those 2 points as my endpoints, right? Do I get the same thing when I use that point and that point? Yeah, when I take those 2, add the x's, 9, divide by 2, 9 over 2. Add your y's, 8, divide by 2, 4, right? What And that's a great property right there. That's something that we need to make sure we see and understand and be able to carry with us beyond this problem. When you take two segments and find their midpoints, and their midpoints are the exact same ordered pair, it tells you that both are bisecting each other. Okay? So when I say they're bisecting each other, that means one bisects the second, and the second bisects the first. Does that make sense? Okay? If I say Dalton and Mr. Fay punched each other, he punched me, I punched him, right? If I say Dalton punched Mr. Fay, there's only one person doing the punching there, right? Okay? So understand when they say each other, it's a reciprocating idea. They're both doing it. If I were to give you this picture here, look at that. Okay? Does anybody know what that shape is? That's a kite. Okay? Look at the midpoint of CB. It's at point E. Okay? Look at the midpoint of AF, that diagonal. It's at point D. Are they the same point? No. So are those bisecting each other? No. Is one of them bisecting the other? Yes. Okay? So there's information there in the way that a statement is worded that we're going to encounter several times throughout this chapter that's very important for us to understand. All right, so here's what happens then. And we're running out of time, so I'm not going to do all of these. But they ask you to find that distance and that distance, then that distance and that distance to verify that they do indeed bisect each other, because they should be equal. The red one should be equal and the black one should be equal, right? Let's do one of those. Let's do, if this is what, 5, 7. So if I do the distance between C and M, I'm going to do 5 minus 9/2 squared plus 7 minus 4 squared, right? How do I subtract fractions? I need a same denominator. So it's got to be a 2, and that turns into a 10 there, right? So give me 1/2 squared. And this is going to give me 3 squared. You may remember how to square a fraction?
Just square both of them.
Okay, so Dalton's right. We got to square both of them. So when I take 1/2 squared, that means 1/2 times 1/2, right? Well, 1 times 1, isn't that 1 squared? Isn't 2 times 2, 2 squared? Does the same thing happen when I have 1/2 cubed? So I have 1 times 1 times 1, which is 1 cubed, 2 times 2 times 2, which is 2 cubed. So I square top, square the bottom. Or cube top, cube bottom. Whatever this power is, you do that to both. So it gives me 1/4 plus 9. If I'm going to add those, what do I need? Common denominator. What's that 9 going to turn into then? 36 over 4. Okay, so that gives me 37 over 4, right? Do you guys remember you can do this? And we're running out of time. I explained it in the other classes, but we're running out of time. We'll see it again at some point again this year and why we can do that, and I'll explain it in greater detail. But what's radical 4 same as? 2. What kind of number is 37? So that's the distance from C to M. You're going to find M to B is the same thing. Now, as you guys have done that assignment, and you found these black distances, A to M and M to F, those should be radical 85 over 2. Radical 85 over 2. Simplified. No new homework, okay? Next week,